Hello, welcome back to Learn Physics. Today's topic we are discussing about the multiple choice questions of current electricity chapter. Okay, so these questions I have taken from your exemplar textbook. Okay, that is NCERT only publishing that book, and from that book some MCQs are given. So I thought I will discuss that one because since that in our now present CBSE exam scheme also MCQs are included, isn't it? So I thought I will start from I will do some MCQs from that exemplar question. Okay, so the first question which I am doing here is two batteries of EMF E1 and E2. E2 greater than E1 and internal resistances R1 and R2 respectively are connected in parallel as shown in figure. The choices are: the equivalent EMF of the two cells is between E1 and E2, that is E1 less than equivalent EMF less than E2. The equivalent EMF E equivalent is smaller than E1. E equivalent is given by E equivalent equals E1 plus E2 always. E equivalent is independent of internal resistance R1 and R2. It's already I gave the question over there. You can find out the choices from there. Okay, so then now I'll draw the diagram. Okay, here it is positive, negative, and from here R1, this is E1. Okay, so from here positive, negative, and from here this is R2. Okay, this is A and this is given as B, this is E2. Okay, how we can find out the equivalent EMF? What will be the, so from the choices you would have understood that where will be the position of E1 and E2 or equivalent EMF? That only it is asked. In the question it is given that E1 is greater than E2, right? No, E2 is greater than E1. E2 is greater than E1. Like that in the question itself it is given. So equivalent EMF at which position it will be coming, whether it is between E1 and E2 or it is greater than E1 or greater than E2 or less than E1 less than E2, that one we should find out. Okay, so how we can find out? So here E equivalent divided by R equivalent. What is this one? E1 by R1 plus E2 by R2. Right. So here we can write it as E1 R2 plus E2 R1 divided by R1 R2. Okay, so E equivalent, the position of E equivalent only we need to find out, right? So R equivalent, what it will be? See, R1 and R2 in which whether they are in series or in parallel, they are in parallel. So what will be R equivalent? R equivalent equals R1 R2 divided by R1 plus R2. That is R equivalent there, since they are in parallel, right? So what will be E equivalent here? E equivalent is equal to E1 R2 plus E2 R1 divided by R1 R2 into R1 R2 divided by R1 plus R2. So R1 R2 and R1 R2 will get cancelled. We will get it as E1 R2 plus E2 R1 divided by R1 plus R2. But in the question it is given as E2 is greater than E1. Right, so this where will be this position of this one? E2 is greater than E1. So this will be a bigger value plus a smaller value divided by, see, whatever be the value of R1 plus R2, since E2 is greater than E1, E equivalent will be always greater than E1. See, E1 into R2 divided by R1 plus R2 plus E2 into this one. So anyway, this E equivalent will be greater than E1. Okay, so E equivalent, where will be the position of in between E1 and E2? Okay, so where the position will be? So E2 is greater and then E equivalent and then it will be E1. Okay, so E1 is the least one. So here in which will be the answer? So first one, E equivalent EMF of the two cells is between E1 and E2. Since E2 is greater than E1, from this equation we can write down that E equivalent is between E1 and E2. Clear? Next question is, resistance R is to be measured using a meter bridge. Student chooses a standard resistance S to be 100 ohm. He finds that the null point is at 2.9 centimeter. He is told to attempt to prove the accuracy. Which of the following is a useful way? So balancing point is given and one resistance also given. So how we can find out which of the following is a useful way? So the options as shown it over here. He should measure L1 more accurately. He should change S to 1000 ohm and repeat the experiment. He should change S to 3 ohm and repeat the experiment. He should give up hope of more accurate measurement with a meter bridge. Okay, so how we can find out? So S value, where it will be, that one we can, where he should use to get a more accurate value. So more accuracy, how he can obtain more accuracy? See, in the case of a meter bridge, P by Q equals R by S. That is the formula, isn't it? Wheatson's bridge formula is P by Q equals R by S. In all the four arms of the same order, if we are getting the value, then it will be more accurate, isn't it? See, if R and S are same values we are getting, P and Q same order we are getting, then it will be the most accurate method, isn't it? That is why we will say, if it is coming to 50, exact 50, that or nearing to 50, if the answer is coming, you will be getting the correct answer, isn't it? So in that way we can find out the more accurate method. At least one side, P by Q and R by S. So and R and S are of same same resistance value, then it will be the more accurate method. So we can first find out what will be the value of R. Okay, so for that, here it is given as S is 100 ohm and length is given as 2.9 centimeter. If length is then P by Q equals R by S. In that, what is P? I am giving it as 2.9. Then what is Q here? 100 minus, because in the meter bridge 2.9 one side means the other side will be 100 minus 2.9 divided by R divided by 100. So what is R here? 2.9 into 100 divided by, so here it is 97.1. Okay, so here the answer will be, it's nearly equal to 3 ohm. R you will get it as, and 3's are right, so nearly equal to 3 ohm. So if I am taking the resistance for the accuracy, if S is equal to 3 ohm, that will be the more accurate method to get the resistance. Okay, so it's nearly equal to 3 ohm. So if we are considering, that is of the same order, if the resistances are coming, then that will be the most accurate way. Okay, so here he should change S to 3 ohm and repeat the experiment to get the accuracy. Okay, so if whatever the value we are getting over here, the same value if you are putting over there as S and repeating the experiment, we will be getting the correct value. Okay, so the next one is, so the here in the previous one answer is C. Okay, two cells of EMF approximately 5 volt and 10 volt are to be accurately compared using a potentiometer of length 400 centimeter. Okay, then the battery that runs the potentiometer should have a voltage of 8 volt. Battery of potentiometer can have a voltage of 15 volt and are adjusted so that the potential drop across the wire slightly exceeds 10 volt. And the next one, the first option of 50 centimeter of wire itself should have a potential drop of 10 volt. Potentiometer is usually used for comparing the resistance and not the voltages. See, anyway that option we can avoid. Okay, here the question is two cells 5 volt and 10 volt to be accurately compared using a potentiometer of length 400 centimeters. So if we need to compare the two voltages 5 volt and 10 volt using a 400 meter wire, what is the condition for that? The potential drop across the 400 meter should be always greater than the given EMFs. Okay, if the potential drop across the 400 meters or 400 centimeters should be greater than the 5 volt and 10 volt. Now, that means it should exceed 10 volt. Then only we will be getting the correct answer. So here which one? That is the condition. Okay, so here the battery of potentiometer can have a voltage of 15 volt and are adjusted so that the potential drop across the wire slightly exceeds 10 volt. Option B, that is correct. Okay, the the resistance which is used over the EMF of the given cells and potential drop across the potentiometer wire. Potentiometer wire should have more potential drop, then only we can compare the EMF. Okay, so the next one, a metal rod of length 10 centimeter and a rectangular cross section of 1 centimeter and half centimeter is connected to a battery across opposite phases. The resistance will be maximum when the battery is connected across 1 centimeter bar half centimeter phase and 10 centimeter bar 1 centimeter phase and 10 centimeter bar half centimeter phase, same irrespective of three phases. That one anyway it won't be, right? Say it won't be same because the resistance length is varying. Okay, so here resistance we should find out for the same set of wire. Okay, for that so here it is 10 centimeter, here it is half centimeter, here it is 1 centimeter. Okay, so we should find out the resistance across 1 cross half and 10 cross 10 by 1 and 10 by half. Okay, so the resistance is maximum at which point? So we should find out the maximum, the resistance at these points, and then only we can find out. Okay, easily, anyway it won't be same, right? Area is different. So according to the area, this area, what will be the resistance? We should find out what is the maximum value. Okay. So here the resistance value is R is equal to rho into L by A. So here for this case R is equal to rho into 1.5. So what will be length? 10 divided by area is 1 into 0.5. Okay, so this one you can calculate, and this one R is equal to rho into L is half divided by 10 into 1. Here R is equal to rho into, what is that, 1 divided by 10 into half. Okay, so here it is 5 rho by 5, and here it is rho by 20, and here it is 20 rho. So which is having maximum R? See, 1 by half centimeter. Rho 20 rho is maximum. So that is the maximum value. So the answer will be here maximum when the battery is connected across 1 centimeter, half centimeter phase. Okay. So the next question is, which of the following characteristics of electrons determine the current in a conductor? Okay, here the options are drift velocity, thermal velocity. Both drift velocity and thermal velocity, neither drift nor thermal velocity. I is equal to, we know I is equal to NAVDE. NAVDE, right? So it is depending on the drift velocity alone. So the answer is drift velocity. Okay, so the next one is Kirchhoff's junction rule is a reflection of. See, we already see in Kirchhoff's laws, which are the Kirchhoff's laws, which are it is a conservation of, yes, it's a conservation of charge and it is not accumulating at one point. Okay, these are the main junction rule and loop rule, what these two are conveying, right? So Kirchhoff's junction rule is a reflection. Junction rule is a reflection of conservation of charge, and charge is not accumulating at the points. So here, conservation of current density of vector, it's not there, conservation of charge. So B, conservation of charge, and the fact that there is no accumulation of charge at the junction. It's not, its current entering is equal to leaving, right? So it is a junction rule is conservation of charge, and charge is not accumulating at the junction. Okay, so these are the. Then next one is the temperature dependence of resistivity of semiconductors, insulators and metals is significantly based on the following factors. So the options are given. The number of charge carriers can change with temperature T. The time interval between two successive collisions can depend on temperature. The length of material can a function of temperature. Mass of carriers is a function of temperature. Temperature dependence of resistivity. Resistivity means rho equals m by n e square 2. Okay, so it is depending on the number density and the collision time interval between the collision, relaxation time, right? So it is depending on number density. So the number of charge carriers can change with the temperature T. Okay, since resistivity is a function of time, so as temperature changes, this n charge carriers changing. Then time interval between two successive collisions can depend on temperature. Time interval two successive collision T, it is depending on this tau also, relaxation time also. So these are the some important questions. So here in the exemplar, I avoided some of the questions because of the diagrams. So it is difficult for me to project it over here in the diagrams. Okay, so this is a small help, I guess. It is useful for you, I guess, because MCQs are coming. We don't have an idea that's to which extent it will be asking. Okay, so anyway, it will be in a below average and above average level. It can come. Okay, so keeping that in mind, and that too in our exemplar means NCERT publishing book only, right? So that one we are giving more importance and giving the questions like this, and maybe it will be useful for you. And if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.